Hey guys, back again for Calc Section 1.5. We're going to be talking about infinite limits. And again, hopefully these videos have been helpful for you guys. I haven't gotten too many questions. Remember, you can always text me at 614-448-7998. Especially if it's just a quick question, maybe a miscommunication with the notes, maybe something I just messed up recording. Just shoot me a quick text. So far, I've been pretty good about responding quickly. Also, if you got a longer question, maybe a problem you need me to work out, my email is colinblisi@gmail.com. Okay, so again, reach out. I haven't heard too much of a need for like the office hour type stuff yet, but it's always available whenever you guys need it. But just keep asking questions. Okay, so diving in today, we're talking about infinite limits. Okay, so remember again, when we start getting infinite limits, that means it doesn't exist. Okay, so now we're going to start combining these last two, the 1.3 and 1.4, to get our 1.5 section. So finding the limit as x approaches 1 from the positive side of the function f of x. Okay, looking at this function up here, we know right now that looking at the denominator that, or if you just recognize this graph, let's just sketch the graph first. Sketching this graph, hopefully we've been studying our parent functions. We know we're going to have an asymptote at this x equals 1 right there. And we're going to have these there we go, right there. All right, so our graph should look something like that. So if we're looking at it now from the positive side, and we're looking at how it approaches from this direction, okay, we see it starts going up to infinity. All right, so we got that for our right side. Now we're going to look at it going from the left side. Okay, as we look at it coming from this direction, we see it goes down towards negative infinity. All right. So the big thing to remember, look, just from our rules from before, it's going to two different limits. So we know it does not exist. It also, we know from before, if it ever goes to infinity or negative infinity, it does not exist. So this limit does not exist. Oh, excuse me. Okay, so definition of an infinite limit. All right, it's a limit as x goes to c of f of x that gives you the result of infinity, positive infinity, or negative infinity. Okay, that's just what we're talking about when we're saying infinite limits. So going down, a quick note. The limit as x goes to c of f of x equals positive or negative infinity, it does not mean the limit exists. Just because we say that's the limit, it does not mean the limit exists, okay? It's the step before the step, if that makes sense. We're identifying that it's like a subcategory of it not existing. It's like, why does it not exist? Because it goes to infinity and negative infinity, okay? So we're still going to show that step, show that it goes to one of the infinities, and then we're going to denote that it does not exist. Okay, and you can even think about it. Our limit, we're looking for a bound behavior. We're looking for something that is bound, and with the limit not existing, it's denoting that it's unbound. Okay, so hopping into examples, you know me, that's the easiest way to go about this stuff. One, here, the first thing, and for most of these, the first thing you're going to want to do is sketch these graphs to the side. Just a little something to help you visualize it going forward. Hopefully you can draw better crosshairs than me. Okay, we can look at this. Hopefully we've been studying our parent functions. We look at that and we know that we got an asymptote at the x equals 2. Okay. Draw a little graph on there. All right, so that's what our graph looks like. And this limit, it's asking us to look at as x approaches 2 from the positive side, okay? So we're looking at it as it goes from that direction, okay? As you can see, it goes up to infinity. All right, we could even check that by plugging in values, right? We could check our x equals 2.1, and that's going to take us to 30. We can check our x equals 2.001, right? We're getting even closer to 2, and that's going to give us 3,000. Okay? You can see that these values just keep going up, 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 up as we get infinitely close to 2. Okay? Now looking at number 2. Okay? Slightly different. We're looking as x approaches 1 from the negative side. Okay? So again, sketch our graph. We have our asymptotes intersecting around here. We're going to have it off the origin. That 1, 3 spot. Okay, so there we go. All right, so our graph should look like that, with it crossing at 1. Oh wait. So it's 1, 2, 3 is where it's crossing. Okay. All right. So again, we can look as it's approaching 1. Looking at our denominator, we know that it's going to be, well, I mean, looking at our graph, from the negative side, right? We're looking at it going that direction. We can see that it's going up towards infinity. Okay. We can test our points again. We have our x equals 0.9. Let's do an x equals 0.999. Okay. We're going to get 2.1 over negative 0.1, which equals 21. And over here, we're going to get negative 2.001 over negative 0.001. That's going to give us. So again, as we get infinitely closer to 1, all right, we could do this all day. We're getting bigger, all right? It's going infinitely up towards infinity. Okay? So let's look at vertical asymptotes. We've been using this strategy a lot, but now we're going to just define it. If f of x approaches the positive or negative infinity, or approaches positive and negative infinity as x approaches c from the right or the left, then the line x equals c is a vertical asymptote. Okay? So let's look at some examples. Like I said, we've been using this strategy a lot. Now we're identifying it as a strategy for certain situations. So if we're finding the vertical asymptotes for 3 through 6. Looking at number 3, we want to make, think about how we define a vertical asymptote. It's when our denominator equals 0, right? When we plug in our c or x or whatever it may be, and it gives us a 0 in the denominator. So we're solving for that equals 0, okay? Pretty easy for a lot of these. You should get an x equals 1/3. If you plug in 1/3, you'll get a 0. That's where the vertical asymptote is. Okay? For 4, again, we're solving for down here. Okay? In this situation, if we're solving, we're actually going to get two answers, right? What does this factor out into? X minus 3, x plus 3. So you're going to get x equals 3, x equals negative 3 as your answers. Okay, so we got 2 vertical asymptotes. All right, for number 5, go down. This should be an easy one. We're setting this denominator equal to 0. Only one result. X equals 0. Okay. And for 6, keep on moving. Same thing we did up there with 4 a little bit. Let's factor out the bottom. I get x minus 2 and an x minus 1. Right, we're saying that equals 0. And that's going to give us x equals 2 and x equals 1. Okay. Remember, these are where the vertical asymptotes are. Okay, pretty easy so far. Solving the denominator, setting it equal to 0, solving for x. Not too bad. Okay, properties of limits. All right, another thing. So far every lesson we've had these little little properties and everything. And again, like I said, you should be writing this stuff down. Make yourself a study book. And the more stuff you get down right now, stuff you get written down, organized, going into next year, especially with this longer break than usual, it's going to be much easier. Okay, you'll be ahead of the game, and you'll be way beyond kids coming out of other classes going into there. Okay, so first thing, let's go through these limits. So, and another thing, it's if f of x, this can also equal negative infinity. Just put that in up there. Okay, so if the limit as x goes to c of f of x equals infinity or negative infinity, and the limit of g of x is the limit, then these properties exist. Okay, so for number one, the sum difference, if we're adding two of them, one's infinite, one's a real limit, okay, it can either be infinity or negative infinity. Okay, and that just has to do with the sign of the limit itself. Okay, so for number two, we're going to look at multiplying them together. So when we multiply, and your limit, and this is the other thing, so if your limit's positive, this is where it matters, you're going to get a positive. Okay, and if it's negative, you're going to get a negative. Okay, it all depends on your limit, or on that limit. But if you could get both just depending on if it's going to positive infinity or negative infinity. Okay, that we'll see some examples that'll clarify that. You'll see how the sign works. All right, and the big one, okay, number three, it's a little different than stuff in the past. Our quotient, remember, the g actually has a limit, and f of x is infinity. Okay, so when we have a limit over infinity, and that could be positive or negative, it's going to give you a 0. Okay, that's the big one to remember. Okay, and something to think about. If you look at your parent functions, if your denominator goes to, if it's going to positive 0 or 0 from the positive side or the negative side, then the reciprocal goes to infinity or negative infinity. Okay, that's just a little rule of thumb. You might see it here in some homework problems, but we'll actually work some of that out. Don't worry too much about it. Okay, examples. So 7, try not to use a graphing calculator for these. We want to examine these in parts. Okay, so don't graph the whole thing. We're going to kind of break these down into parts like our properties and see it as a whole going forward. Okay, so 7, we're looking at the limit as x approaches 0 from the positive side of 3 plus 1 over x. Okay, so we should know from our previous properties that the limit of 3 is 3. Okay, the limit going from the positive side of 1 over x. All right, do we remember what that looks like? Oops. 1 over, this case, the graph's going to look something like. Okay. That 3, all it does is move that horizontal asymptote up to the y equals 3 spot. But we know that because if we look at it from the positive side, it's going up towards infinity. Right? If we look at it going from the negative side, 3 plus 1 over x, it's the same thing. It's actually going down to negative infinity. Okay? So again, that's why when we take the limit of the whole thing, we get it does not exist. Okay. So these do not equal, right? That's why it does not exist. You get a negative infinity and an infinity. Okay? Looking over at 8. Now we got something that's a little funky. Remember, this is like the big division sign right there over another fraction. Okay, so let's just look at this in parts, like our quotient rule. Okay, you see how we can take the limit of g of x and f of x. So let's just look at the top. When you look at that top function, all right, we can tell that has a limit of 2. Okay, if we're approaching it from the -1, if you went and graphed that, as it approaches 1 from the negative side, you get a limit of 2. Okay. Now on the bottom, we know that our 1 over x graph, especially when you start approaching things from 1, it's from the stuff we did previously, we know if we plug in 1 right here, we're going to get 0 in the denominator, and that's going to give us an asymptote. Asymptote at 1. Okay. Sketching this graph should look something like this guy. Right? Okay. And so now when we look at the stuff we look at the denominator, the 1 over x minus 1, and we approach it from the negative side, okay? Because this graph right here is just the denominator. All right, understand that. So when we're looking at just that denominator graph, okay, and we're approaching it from the negative side, it goes to negative infinity. So let me actually clean this up a little bit. Okay. Okay, so coming down here, we got that our numerator is going to be 2, right? X squared plus 1. As it approaches 1 from the negative side, it's going to give us a 2. Okay, we decided that 1 over x minus 1 is going to give us a negative infinity, right? It goes down to negative infinity. Oop, that's just an 8. Okay, so our quotient rule property tells us that when we have a limit over positive or negative infinity, it's going to always equal 0. Okay? So I did a whole lot there to show you that it just that it's 0, okay? So make sure you understand you can break up those limits to the top and the bottom. Find the parts, understand the properties to get your 0. Okay? And now for number 9. Number 9. All right? We got the limit as x goes to the positive 3, or 3 from the positive side. So again, we're going to break it up. We're going to look at our top part and our bottom part. So for the top, right, if you plug in, this is one of those ones you can just plug in. You plug in 3, what are you going to get? 9. Okay, so our limit on the top is 9. Now when we look at the bottom, we know that there's an asymptote, okay? And from the stuff that we did previously, we actually know that there's 2 asymptotes because we got 2 x's that can be asymptotes in this equation. All right? So when we graph this guy, we're going to have something that looks a little chaotic. Let's try it out, though. Okay, we're going to have this asymptote here. Then we're going to have our 2 vertical ones. Okay, I didn't really draw this with enough room. Let's try again. Alright, we got stuff going up here. We got something that looks like that. Okay, these are at These are at 3 and -3. Okay, that's where our asymptotes are. So looking at the graph, we get that as it approaches from the positive 3 side, as it approaches 3 from the positive side, that we go up to positive infinity, right? Okay. It goes up to positive infinity. This is that 3 line right here. Okay. So if we have a positive infinity on the bottom, I don't know if you remember our rules up here. If we ever have a limit on the bottom, it's just going to give us infinity. Okay. Okay, going over to number 10. We have something with some cotangent in it, all right? So again, we can break this up based off of our properties. We know that this is the same thing as 3 and our cotangent as it goes to 0. Again, I don't know if you remember cotangent graphs. It's going to be positive infinity, but we can look at why that is. Okay, so it's the same thing. You can even break this down if this helps. Limit as x goes to positive 0 of 3 over tangent, right? That's the same thing. You could break it down and you could say the limit of x going to 0 positive of 3 times cosine over sine. Okay, and when you think about that, we know that it's going to be infinity because you're going to get your infinity in the denominator, right? Your sine's going to be a denominator. Your ones, it's going to make it an infinity. Whenever you get that infinity in the denominator without a real, or in the numerator without a real limit above, it's going to be infinity. Okay? So we can tell that by the graph of... Actually, let's look at this. Let's look at this graph of tangent. I like this graph better. So if we look at the tangent graph, that's that one that it kind of does one of these, right? Okay, so you can see that as it approaches 0, it approaches it from above, and then it goes to infinity. All right, it's approaching 0 from above, or it's going to infinity, right? So we know that's a positive, so that's why we're getting a positive infinity. Okay, if that makes sense. Because our cotangent graph, our 3 times cotangent graph is going to look... Or wait, no, that's it. All right. So out of all this, you get that 3 times infinity, so you get that it goes to infinity. Okay, 11. And then I'm going to write just a quick study guide for all this stuff going forward. Okay, so we're looking at x going to 0 from the negative side. We got a 2 over sine of x. The big thing to think about is, again, breaking this up. So 2, we know that our limit's going to be 2. And sine, as it approaches 0 from either side, right, it's going to be 0. Okay, and we can think about it. It's coming from the negative side up, right? Our sine wave, our sine graph should look like something like right on that 0. It's coming from that negative side, from the negative. Okay, and so when we have 2 over 0, and this is the other thing. So we got to recognize that this is coming from the negative side. So you could think about this as like kind of being like a negative 0. Okay, it's coming from the negative side. So we can say we know that it's going towards negative infinity. Okay. Another way to look at this is you can break this down. Again, just like we did for 10, you can switch it up a little bit. You could look at this as 2 times cosecant x. Okay. And with cosecant x, as cosecant x approaches, I don't know if you guys remember these graphs. Again, cosecant graphs, if you look at this as a whole, they're the ones that have these. Why is this so faded? Oh, that's why. That has these guys that look like this. Right? That's cosecant. So now we're not looking at it as just a part. We're not looking at just sine of x. We're looking at it as cosecant as a whole. So if you look now as it goes to 0, you're looking at this right here. Okay? You see how that parabola is going down towards negative infinity? Okay? So that would be the same thing as then we would say 2 times negative infinity, which would give you negative infinity. Okay, so when you're looking at it as parts, like if we're just looking at the sine part, like we did originally, and we got that 0, the reason why I put that negative there is because it matters what direction it's coming from. It's coming from below or from above. Because remember, the direction, that kind of goes back to those rules. And actually, I'll write that rule too. But if whatever direction it's coming from, when you break it down into those parts, that kind of tells you, that gives you the sign you should use so you know if it's negative infinity or positive infinity. If you want to look at it as a whole, that'll be your check, like we did with cosecant. We saw that cosecant, when we did it as a whole, it actually goes to negative infinity, so that checked our rule about the reciprocal. Okay, I kind of stated that rule early on, but we'll write it all down here to finish. Not that. Let's just go new really quick. We're gonna sketch it. So the first thing, let's write down some of these limit rules. Okay. Let's change up this color to something a little lighter. Let's go with orange. All right. So let's talk about our limits. All right. So if you get 0 over 0, that means you got to do something. All right. I'm going to write just do something. But what that means is that's like where we had to manipulate. Oh my gosh, my handwriting's terrible. We have to manipulate the equation a little bit to make it something that we can work with. Okay. If you get 0 over a number, all right, that's going to be 0. Okay, if you get a number over 0, that's going to either be infinity or negative infinity. Okay, if you get a number over positive or negative infinity, it's going to be 0. Okay, if you got number plus infinity, it's going to equal infinity. Okay? Number plus negative infinity is going to equal negative infinity. You guessed it. Okay? Now positive numbers, and think about this. If you got just positive number, negative number, okay, and you're multiplying it times infinity, it's going to equal infinity. Okay? You got a negative number times infinity, it's going to equal negative infinity. Okay? So these are some good rules. Some good rules to have down. The final rule that we touched on, I just kind of said, and then we saw how it came into play there with the last problem. But let's just do it like this. Okay, another thing. I want you guys to look at parent functions. Okay. If denominator goes to positive 0, or 0 from the positive side, right? 0 from the positive side or 0 from the negative side, okay? Then the reciprocal goes to positive infinity or negative infinity. Okay, so that's like we were talking about with the sine. We saw that the sine approached 0 from the negative side or from below. Okay, so then it the reciprocal cosecant, we knew that it was negative infinity because sine approached it from below, so it's negative infinity. If it was going to approach it from above, it would be a positive infinity. All right. One last thing. Actually, I'm going to go through and we can label. Oh, no, that's next week's. Okay. If you guys got any questions about this stuff going forward, please, like I said, reach out, let me know. Anything in the notes clarified, anything in the notes with the answers posted that needs clarified, just let me know. Phone number, emails at the top.